This is part of our Dalton series of seminars. We have a speaker today, Zainab. She's going to talk to us about emerging trends in fusion technology. And it's not just the engineering technological side, is it? It's more like marketing and
Yeah, it's a lot of the investment trends, partnerships, and the activities that are shaping the industry.
and there's a contrast with SMRs and how people like Microsoft, Amazon, and Google are also looking into stuff to spearhead their own energy demands. So Zainab's with the Cleantech Group. What was actually based? Sorry, is that in America?
So it's actually technically most of my team is based in London, but it's technically headquartered in the US. Yeah, I'm one of the few people from the US.
Okay. And then we need a shout out to Binghamton University, where she's.
Yeah.
Yeah. I'll leave it to you.
Okay, great. Well, thank you for the introduction. I wanted to thank you all for attending today's session, and also just thank Dr. Anika Khan for allowing me to present. It's going to be an incredible opportunity. So just wanted to provide some background on myself and also my company, Cleantech Group.
I just say sorry in the virtual. I forgot to mention the if you have questions, there's a Q&A window where you can raise your hand and say something as a plan.
Thank you. Great, that sounds good. So Cleantech Group is essentially a research-driven company that helps corporates, public sector, investors, and others identify, assess, and engage with the innovative solutions and opportunities that are related to the world's massive and growing environmental and climate challenges. So we take a very broad brush on how we look at different clean tech sectors. We have three main business units. One is having a research platform. We do provide consulting services to our clients, and we also host events. So we work with a very wide range of clients. Some of them include corporates from different industries. We work with various financial institutions. So these include firms like private equity firms, banks, venture capital groups. We also work with different nonprofits, and these can include accelerators, universities, and governments. We engage with our clients in a variety of different ways, but primarily we have a database platform called i3, which houses information on over 40,000 companies. So many of our clients are interested in keeping track on different investment trends, partnerships, any specific technical milestones that these companies might be progressing with. And we do this across a wide variety of clean tech sectors. And we also have specific research insights where we look at specific topics and do a deep dive on challenges, drivers, and any key companies and investors in those particular sectors. So my team and I, we cover a very broad range of clean tech sectors. We look at this in 6 main verticals. This includes agriculture and food, energy and power, which is I'm the associate for energy and power. I work alongside my colleague Selena Law to track trends in this sector. We also have a vertical for materials and chemicals, resources and environment, transportation and logistics, and waste and recycling. So as we go through these sectors, as I mentioned earlier, we try to take a look at who are some of the key companies in this space, who are the investors, and if there are certain either regions where we're seeing particular investments or technology types, and we try to understand what those drivers are, where the challenges might be, and what themes we might be able to look at a little bit further. So my colleague and I, we look at a few different sectors within energy and power. This includes advanced nuclear, so small modular reactors, and also fusion. But we also look at a broad range of different subtopics as well. We look at long duration energy storage, different battery technologies, grid resiliency, data centers, and a few other topics, and industrial decarbonization and building decarbonization. So because we kind of have a pretty broad look at different sectors, I wanted to incorporate some of the clean tech themes that we're seeing across these sectors and how it might impact the advanced nuclear and fusion landscape. So before I go in, I'm just curious about who some of the individuals are and what your backgrounds are. So if anyone wants to share what departments they're from or any of the research that you're doing, I'd love to hear.
This call kind of work in the nuclear graphite field.
Sorry, which one?
Graphite. So
okay, graphite.
Graphite moderators for high temperature reactors.
Yeah.
And some more consultative devices. So we focus on that.
Great. Does anyone else want to share any research that they're working on?
Fusion people in the room.
Few fusion people feel?
Yeah. So Korea, Shanghai, and some fusion and materials more widely as well as clean materials.
Oh, so nuclear materials and fusion?
Yeah.
Anything specific in the materials or fusion?
Tungsten, mostly.
Tungsten.
Looking at radiation damage. Yeah. Chemical properties. Yeah, additive manufacturing.
Additive manufacturing. Okay, great. Yeah, no, I appreciate that background. That's really helpful. So I do have a few slides on different nuclear technologies, both for small modular reactors and the fusion systems themselves. I don't want to spend too much time on the specific nuances between each different technology type, just because I feel like a lot of that is available online. And if you go to different companies, they'll tell you what the different challenges and advantages are between, tokamaks and stellarators, and there's quite a lot of discourse already there. But what I want to do is talk a bit more about what some of the overall trends are that are going to affect both the nuclear industry, both for advanced nuclear and fusion. And I think that'll give a picture on how some of the impacts might have on those industries and what those industries might look like in the future. So without going too in detail, I just want to talk a little bit about small modular reactors and then the benefits that come associated with being small and modular. So I think what's really interesting about these technologies are the fact that different applications can open up for nuclear. You have traditional applications like district heating, desalination, and grid scale energy production that can be used with large power fleets for nuclear. But when we're thinking about small modular reactors and micro reactors, the fact that they have smaller land footprints, potentially have lower lead times, and reduced cost, I think will be really interesting to see how they are deployed in the future. And they can also be applicable in areas where grid infrastructure and transmission may be limited. So this is a little bit of a busy slide. I'm not going to get too in detail here, but I just wanted to call out a few key players that some of you might already be familiar with. There are a variety of different technologies within the small modular reactor space. You have your light water reactors, gas-cooled reactors, molten salt reactors, and fast spectrum reactors. A few of the companies you might be familiar with include Oklo, based in California, Nucleo, based in France, and TerraPower, that's also based in the US. That's kind of Bill Gates' company on the fast spectrum side. For molten salt, for molten salt reactors, one of the companies that's recently been in the news is Kairos Power. They've been oh yeah, sorry, do you have a question?
Sorry, just will we be able to get this PowerPoint off?
So I can see which slides I can send. I might send the redacted version because of the company.
This list of companies.
But this
Everyone
is
likes this slide.
Yeah.
so it's very difficult to have an exact science because multiple companies are working on multiple reactor types. This is just good to kind of paint like a broad spectrum when you're having a conversation on what specific technologies, what specific companies might be looking at, where they are, and kind of generally speaking, what are some of the pros and cons with different reactor models? So yeah, happy to be in touch after as well. But yeah, so on the molten salt reactor side, one of the more well-known companies at the moment is Kairos Power because they've recently engaged in a partnership with Google. I'll dive into the details of that partnership in a little bit. Another key company to call out is X Energy. They're developing an XE100 reactor and also a micro reactor. I wanted to call out that gas-cooled reactor system. So I'm going to be talking about some of the partnerships and investments in this space. So there is quite a bit of momentum, but unfortunately there are challenges, and those challenges can result in bankruptcy. So I'll just say nuclear, which is listed as a micro reactor, and unfortunately I might have to remove from the slide in the future because they've recently filed for Chapter 11 bankruptcy. So I'll be keeping an eye on different trends and companies and how they're progressing as well. So this slide is generally a very evolving slide within our company. A few other companies I wanted to quickly include Last Energy, Westinghouse, NuScale, and GE Hitachi. These are pretty much more of the standard light water reactors that I'm sure many in this room are familiar with as well. So I don't want to spend too much time on this slide because it's very easy to get very technical, but at a high level, I think the fact that light water reactors can leverage existing supply chains, fuels, and coolants will allow them to advance in certain areas. And then you also have different types of reactors that use different coolants. So high temperature gas cooled reactors, which probably use flowing helium gas in many cases, liquid metal cooled fast reactors, which can use sodium as a coolant, and then molten salt reactors, which can use fluoride and chloride salts as coolants as well. I'll just leave this on here for a second. So this is another slide I think I should be able to share later because pretty much everything on here is public information. These are essentially some of the major investments that we've seen in the past few years. This isn't everything, but just some of the key investments that I did want to call out. So NuScale has received investments from a few different players. These include Samsung, Doosan, and GS. I think what's interesting to call out here is that many of these players are not based in the US, they're based in Asia, namely Korea. And so the fact that they're engaging with US companies is a good sign, just showing that there is a lot of foreign cooperation and development for nuclear technologies. Another one that I wanted to call out is TerraPower. TerraPower received around a $750 million private equity round with SK Innovations, which is also based out of Korea, and a few other players as well. Another company out of the many companies on here that I think are worth mentioning is Nuclear, which is based in France. They raised quite a bit of funding throughout 2022. They had $300 million raised. And then just this past year, they've had a few different extension rounds. And then I'll get into this later, but there's been numerous case studies where different types of technology providers and data centers have been engaging with nuclear technologies. These include Amazon supporting X Energy as they raised a $500 million round, and Amazon working with a few other players in the region as well, especially in Virginia and Washington. And then I'll get into a little bit of the details between TerraPower and Google's partnership as well. If there are any questions on this side, I can take it now before I move on. Yeah, okay, great. So I want to preface this slide a little bit. I would be hesitant to send this out because there's a little bit of nuance. So when we're thinking about private investments going into the nuclear space, not everything is publicly disclosed. So although my job is to track press releases and understand where investors are investing their money, a lot of times you have high net worth individuals or sometimes other companies who invest in companies without having any press releases. So just take this slide maybe with a grain of salt as you think about where investments are going. On top of that, this is mostly tracking venture investments. So we're thinking about seed, Series A, B, and growths. There are certain types of funding, whether that's debt funding or grants, that's not included. And this is mostly just to show where private companies and institutions are putting their money. And then on top of that, you have specific trends where you have regions that are very, 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 very public sector led. So regions like Asia Pacific, you don't really see too much of here. That's because they're orange. There's like a few deals that you can see in the number of deals. Essentially, there hasn't been that many private sector investments in fusion and small modular reactor, sorry, not fusion, in advanced nuclear in the same way that we've seen in North America and Europe. One of the key dynamics I wanted to call out is the fact that there have been pretty substantial high volume deals in North America. And as I talk about the relationship between data centers and nuclear power, I just wanted to highlight that close to 40 to 50% of the world's data centers are located in the US. So that may play a role in the future as we think about where investments are going, who the investors are, and where the companies are located. Another two companies I want to call out are, well, I'll just focus on Core Power for now. So I think Core Power is an interesting company because they're based, I believe they're in the UK. I know they're in Europe, and they're focusing on nuclear technologies for marine applications. And they've also been partnering pretty substantially with different players in Asia due to just the growing shipping landscape in Asia as well. So maybe before I move on to the next slide, I'm just curious. Does anyone want to share potentially any challenges that they think are associated with growing nuclear technologies on a global level? This can be a pretty big question. Regulations. Okay, anyone else want to share? Public acceptance is a big one.
Risk involved.
Yeah, financial risk is a very big one, and I'll get into that in a little bit. Any other potential challenges?
I think it's a build.
Yeah. So I think those are all really good examples. I've listed a couple of them here. We can get into them a little bit more, but I think public perception I heard was a big one that involves both public perception for radioactive waste, potentially danger, any misconceptions there are on how nuclear technologies actually work. And financial risk and acceptance is also a really important one. So there's also public perception on how nuclear economics work, right? So when you're thinking about financial institutions, banks, private investors who want to engage in the nuclear industry, there are public perceptions on how they think nuclear might be profitable in the future or not. So Anika, Dr. Han and I were talking about this a little bit earlier, but like if the perception for the nuclear industry as a whole is that nuclear projects are not on time and they're not on budget, that's not necessarily good for the financing aspect of new nuclear technologies, especially when you're thinking about innovators who are trying to look and develop first of a kind projects and pilots. So I think I discussed most of these, but I think one of the interesting other dynamics worth calling out are the fact that solar, wind, and gas can potentially be very, very cheap. So if nuclear is trying to compete with different energy sources like those, you really need to think about when nuclear technologies might be the most applicable. And hopefully I'll spend the next few slides talking about where certain industries are very well suited for nuclear technologies. Another point that I heard that I want to call out again is supply chains. So I think as we think about SMRs and who the different players are, many of these players are going to be requiring HALEU fuel. So understanding how they plan on developing out the supply chains for that will be pretty critical. Okay, so I'm going to talk a little bit about the different drivers potentially advancing nuclear technologies. Oh yeah, go ahead.
I don't know if you're on a different slide on the.
Oh, so sorry.
Yeah, no worries.
Yeah. I appreciate that. I forgot that they weren't connected. So maybe before I go on, I'm just curious, how many of you are aware of the different forecasts for energy demands for data centers? Are you familiar with just like some of the IEA projections or just like any concerns or maybe reservations on like what those forecasts might look like?
A little bit. I hear it's quite dramatic.
You hear it's quite dramatic? I talked to a lot of people who think that as well. Anyone else? So if I said hypothetically a data center campus was going to consume 1 gigawatt of energy, would you think that's realistic, unrealistic, not likely?
I mean, with advancing computer processing powers and everything, it's possible.
Yeah. So I kind of came in when I was doing research on the data center landscape, also thinking that a lot of the different forecasts were pretty overblown. And I think when you think about future projections, it's always easy to be on one side or another. Only time can really tell like whether those future projections are true or not. But from a number of people I spoke within the data center industry, those who are building out data centers, those who are working with hyperscalers, so like hyperscalers like Microsoft, AWS, different institutions like those, a lot of them will say that the forecasts are underestimates, which is slightly concerning. But it's one of those things in perspective to keep in mind as we think about what the overall trends from data centers will be. And so I'm going to talk a little bit about data centers, but other demands I want to talk about eventually include the high temperature heat demands for industrial customers, and also why some of the challenges associated with wind and solar may be opportunities for nuclear, especially as we think about aging grid infrastructure. So we were talking a little bit about the International Energy Agency. One of their statistics suggests that data centers currently consume 1 to 2% of overall global power, and this can potentially reach 3 to 4% by the end of the decade. I think you can see it here on this graph. So there's 3 different cases. For around 2026, the high case estimates that around 1,000 terawatt hours of energy could be consumed by the data center sector. So this includes AI and cryptocurrencies. The medium case suggests around 800 terawatt hours. And then the lower estimates suggest around 600 terawatt hours, all of which are pretty substantial. And I also just wanted to highlight again that there are conversations happening today where hyperscalers and different data center operators are potentially thinking about what would it look like to have a data center campus that does operate and require at least 1 gigawatt of energy. So I just spent some time talking. Oh, yeah.
You mean by campus? Sorry. So you're saying data center campus, but so I think all of us are campuses where students study.
Yeah, so I think when people think of like a data center, people think of one building. But when you think about a data center campus, it might be multiple buildings all together that essentially consume 1 gigawatt as opposed to one building that just consumes 1 gigawatt.
Sure.
Does that make sense?
Yeah.
Are there any other questions? Okay, great. So I just spent some time talking about the demands. We know there's this incredible growing amount of demand. How do we potentially build that out? So one of the problems that we've talked a little bit are just the costs associated with nuclear. So one of the interesting things about Microsoft, Google, and Amazon, they're all particularly well funded. So they have money. They also have a challenge where they have net zero commitments. that they're not necessarily reaching. So both Google and Microsoft have shared that their emissions have been growing in the past few years. Google's has increased 48% since 2019, and Microsoft has increased 30% since 2020. So this is really important because these players who do need energy almost immediately, they need to meet their climate goals, and they are potentially willing to pay a premium for energy and to build out potentially first-of-a-kind projects and work alongside the advanced nuclear industry to develop projects. Okay, so has anyone heard of any of these recent case studies? There's like a couple ones that have been in the news. So I think the first one I want to talk about is Microsoft and Constellation, and there are a few different dynamics at play here that I think are really important for the industry. One is that Microsoft will be working with Constellation Energy to support a project in 3 Mile Island. I'm not sure how many of you are familiar with the US nuclear landscape, but the 3 Mile Island Unit 2 had notoriously suffered a partial meltdown in 1979. So the fact that Microsoft is willing to kind of take on the marketing risk associated with opening up an existing nuclear plant at the site is pretty. It's worth noticing. It's not necessarily a small thing, especially when we talked about how market perception was such a major problem for the nuclear industry. The fact that they're working at the site and potentially rebranding it to be a clean energy center is something that I think will be really important as we think about how data centers and technology providers work with nuclear technologies as they move forward. Another point to call out is Microsoft is going to be purchasing all of the electricity generated at this site. So it's not necessarily that they're just working on this site and then sharing the electricity with other consumers. They will be purchasing all of it. And there are different estimates that suggest that Microsoft will be paying a little bit of a premium on the energy generated. There are different estimates that suggest what energy can cost around that region. Some estimates say it could be around $60 per megawatt hour. But if Microsoft is potentially paying north of $90 per megawatt hour, that just shows their willingness to pay a premium for nuclear technologies. Okay, let's think. So a few of the other major tech companies that are involved in the space are Amazon, Google, and Equinix and Wyoming hyperscalers. They're different data center companies. Amazon has announced multiple deals with nuclear players. They have led a $500 million investment round in X Energy and will work to develop 5 gigawatts of nuclear projects by 2039. Google will also partner with Kairos Power to deploy 500 megawatts of nuclear power by 2035. And Oklo will be working with Equinix to develop a variety of different units to support their data centers as well. I think what's important to notice with Oklo specifically, data centers account for the majority of their customer base. They will essentially account for 600 megawatts of around 1,350 megawatts of customer supply for Oklo. So one thing that I did want to note on this slide too is that you have, I'll also talk about this slide for a little bit. So one thing that I did want to note about this slide is we're talking about advanced nuclear, but a lot of the players involved with these technology providers are associated with fusion as well. So you have Bill Gates from Microsoft, who's working closely with Breakthrough Energy. Breakthrough Energy has invested in a wide variety of fusion technologies. Jeff Bezos from Amazon has invested in general fusion. Google has been working with TAE Technologies, and I think they're also a founder of Commonwealth Fusion Systems. And then Oklo, the chairman, is Sam Altman, who's very famously a huge supporter of the nuclear industry, both for advanced nuclear and for fusion as well. Okay, so this is, again, a pretty busy slide. I'm not going to get into all of it. I just kind of want to use this slide to talk about the breadth of technologies that are going to be needed to solve the problem of decarbonizing data centers. You have a few different technologies on the left-hand side. That's for renewable generation. But outside of the energy production needed to meet the demands, there are various organizations and companies that are looking to optimize the data centers themselves, whether that's integrating different storage and flexibility solutions, using AI to optimize the plant itself, and also supporting different cooling and waste heat applications where you can reduce the amount of heat and energy required to cool these systems as a whole. Roughly 40% of a data center's energy is used for cooling. So if cooling technologies are able to scale, hopefully they can potentially reduce some of the energy requirements for data centers. But it's one of those weird balances where as systems get more and more efficient, sometimes more and more of them get built out. So we're still going to need quite a bit of energy production to meet the needs of data centers. Does anyone have any questions on data centers so far before I move on? Okay, so another key driver for the nuclear industry will also be the demands coming for decarbonized heat. As new nuclear reactor models can achieve higher temperatures, they can also unlock new markets. So this is a really great graph from the Royal Society. Some of you may have seen it before. It just shows the different temperatures that can be reached through different nuclear and small modular reactor types. I think the key area that you want to look at is between that 600 and 900 degrees Celsius mark. This is where industries such as petrochemical manufacturing, pulp and paper production, steam electrolysis, and potentially even steel manufacturing. A lot of these processes occur at that over 600 degrees Celsius mark. So if nuclear technologies can further decarbonize these sectors, they could potentially have immense impact at unlocking entirely new markets. One other thing to note on the slide is that many of the technologies that do reach higher temperatures, they do require HALEU and TRISO fuels to reach those higher temperatures. So many of these companies will have to work on developing those supply chains as well. Okay, so one of the case studies that I wanted to call out is X Energy's partnership with Dow. So this has the potential to be one of the first grid scale deployments of SMRs at an industrial site. This is anticipated to come online by 2030. Dow and X Energy will develop around 4 high temperature gas cooled reactors at their Seadrift site in Texas. This site essentially is used to support manufacturing of different materials. They're hoping to reduce emissions by around 440,000 metric tons of CO2 per year. Around 4 billion pounds of materials are produced annually at this site, and they have various applications across a number of industries. These industries can include food preservation, footwear, wire insulation, and also packaging, pharmaceuticals, and others. So this is important just to show a model of like we saw with data centers, an example of a partnership with an industrial corporate that can further deploy nuclear technologies at a time where there might be challenges associated with nuclear. Okay. So one of the other dynamics I want to talk about there are certain challenges associated with deploying wind and solar, and many of the bottlenecks associated with those deployments can be centered back to grid infrastructure. So there are, again, quite a few challenges associated with grid infrastructure, but I think this also presents itself as an opportunity for nuclear. So in areas where wind and solar may be difficult to deploy, whether there may be a lack of solar, a lack of wind, or if there just aren't the land requirements there are potentials for small modular reactors and nuclear reactors to be deployed on site. Some of the challenges associated with the grid include increasing number of grid outages that result from a changing climate. So if we're looking at the history of the grid for the past few decades, there have been a number of power outages that were a result due to changing weather events. And as climate change increases, there will likely be further grid outages in this space. On top of that, the grid was designed many years ago, so parts of it are very outdated. As we think about different trends in different clean tech spaces, whether that's the increase of EVs in the transportation sector or heat pumps in more decarbonizing buildings, we're going to see more electrification trends that are going to require more electricity and more electricity to be transmitted. Another key dynamic I want to call out are the fact that wind and solar are variable. So because there are going to be fluctuations where there might be times of high solar, times where there's more wind, and the peak demand for energy may not necessarily align with when peak energy generation is happening, there are going to have to be inputs to the grid to kind of make improve and like make it easier for electricity to be transmitted during those times. So again, this is kind of like one of those slides where this is how essentially we think about the grid resiliency and just like the grid infrastructure landscape. There are quite a number of companies on here. Essentially, this is just to show how different types of solutions can be used to tackle problems of transmission and distribution. There are quite a number of these companies that are using AI, sensors, and different types of systems to help manage and control the grid infrastructure. So one of the key dynamics I also wanted to call out here is the fact that sometimes when you're working with utilities, they're a little bit hesitant to engage new technologies. It might be easier to work with software solutions that are easier to integrate with hardware systems as opposed to actually integrating new hardware technologies itself. So when we're thinking about as grids look to modernize, we'll probably see more software solutions be deployed as opposed to hardware solutions. That being said, there are some hardware solutions that are a little bit easier to integrate over others. In the US, we're seeing advanced conductors receive more investments and partnerships. They essentially allow wires to have a better capacity to transmit electricity and are pretty easy drop-in solutions. But as we're thinking about transmission capacity improvements, I also want to call out high temperature superconductors. I'm sure many of you are aware of their impact in the fusion space, and I did want to talk about this technology a little bit further. So there's this one company I've been in touch with. They're pretty interesting. They are essentially using high temperature superconductors that are cooled with a nitrogen system to allow for transmission improvements for up to 5 to 10 times greater current capacity. So this is really important because a lot of the solutions I showed earlier, they can improve transmission capacity, but they might range around 50% to around maybe 2 times what the improvements are. So with high temperature superconductors, if you can get 5 to 10 times, that's a huge step change improvement. So when we're thinking about, data centers or institutions that are going to be requiring exceptional amounts of energy production, solutions like this are going to be critically important. There are a few other key dynamics with high temperature superconductors for transmission that I did want to call out. One of them is the fact that although they may be expensive now, there is the potential to have substantial cost reductions there are estimates that they can be reduced up to 2 to 6 times due to the growing demands from the fusion industry. On top of that, there are cooling systems that will protect these wires against extreme heat and weather environments and will allow for operations in a variety of different climates. So one of the challenges with existing wires is as climate change increases and temperatures increase, there is this opportunity for these wires to sag. So when you're thinking about an environment where temperatures are sagging, there's also the higher likelihood that wildfires can occur because those lines can get tangled up or they can cause outages. So there are challenges associated with that. So if you have high temperature superconductors that can essentially withstand a change in climate and extreme heat, that's also an added benefit. Another key interesting point about high temperature superconductors, I'm a really big fan of these technologies, especially for grid, is the fact that you are able to have higher current, but you also are operating at a lower voltage. So a lot of the regulations associated with high voltage equipment may not necessarily apply to high temperature superconducting technologies. But unfortunately, one of the sad things with any type of innovation is no matter how good it sounds, there are always challenges with deployment. One of those is the fact that I mentioned earlier is that utilities are a little bit slow moving. There aren't necessarily enough incentives for utilities to adopt more efficient technologies just due to the fact that they are essentially a regulatory agent or a regulatory body. There are different dynamics at place that don't necessarily make them incentivized to adopt entirely new technologies that may put other infrastructure at risk, especially if technologies like high temperature superconductors haven't been de-risked at scale for grid applications. So that being said, there are a few different policies that are going to be used to deploy technologies like high temperature superconductors. There's like the IRA, there's different programs associated with innovation pilots for technologies like this to grow, but this was one of the ones I just wanted to call out because it just goes to show the wider trends of how technologies designed for the fusion industry may also have applications outside as well. So I do have some more trends and insights on the fusion landscape. I think now might be a good time to pause and take any other questions. Go ahead.
So I had a question about the heat applications, slide. I think
Yeah.
slide. So I think most of those were, fission, reactors, right?
Yeah.
I'm using a trick with the fusion industry. We keep saying we wanna, generate, electricity and obviously that's important in the
Yeah.
future, but even before we can get to that technological, stage, should we be utilizing the heat that's generated from fusion reactors for these kind of applications?
Yeah, I think that's a really good point, because if you look at some of the milestones that fusion companies are achieving, they're reaching exceptionally high temperatures. I think one of the challenges associated with that is that there's not really an economic model to provide revenue for fusion industries just yet. So if you can potentially have a way where the money that you're generating from high heat applications is more than the amount of essentially money that's being used to develop whatever stage of the fusion reactor you're developing, I think that economic model might be a little bit tricky to work out, but it is potentially a really important way for fusion companies to generate revenue. I think one key point to talk about is there's all this kind of hype about fusion, again, generating electricity, but you have different companies who are looking to raise funds and generate revenue outside of looking at just the investor landscape, right? Because the investor landscape can be pretty limiting. If everyone's competing for the same dollars, it might not necessarily be the best way to scale, especially when there's a limited amount of essentially dollars in the investor pool. So looking at ways to commercialize different technologies that are being developed for that company, for that reactor model, or for that technology, I think is a really great way to, potentially generate revenue as they look to scale. Any other questions?
The following slide, please. Is it five? Yeah, this
So, yeah.
this one, yeah. The last point with like over £4 billion materials produced annually. Is
Yeah.
it with like heat or with the electricity?
It's both. So essentially the Seadrift is a campus, so they use electricity and high heat to support their manufacturing processes. So for most of these manufacturing processes, steam is used to kind of move the process forward, but the entire Seadrift campus itself also requires electricity. So it's kind of a combination of both.
So I'm familiar with like cogeneration, like you have like another plant that uses the heat, but
Yeah.
if you're supplying the heat to like multiple industries, like I don't know how the infrastructure works.
So this is actually really interesting because it's essentially chemical manufacturing. So the materials used are used in a variety of industries, but I imagine the processes are very similar at that one location. It's just that the applications for those petrochemicals might be pretty varied. Any other questions? Okay, great. So I'm not going to spend, I'm not gonna spend too much time talking about the physics of fusion because I'm sure there's quite a few people here who can do it better than me. Just at a high level, I think it's important to just talk about how fusion can generate energy just from fusing two lighter atoms or isotopes of hydrogen together, and how there are benefits when compared to fission, especially how there are essentially, generally speaking, lower levels of radioactive waste produced, and there's just like more security associated with the less likelihood of having a meltdown. So the Fusion Industry Association does a pretty good job of outlining this as well, but this is just an overall overview of some different fusion technologies kind of categorized by sector. A few of the big names are Commonwealth Fusion Systems for tokamaks. Another one is Energy Singularity based in China, Tokamak Energy, which is based right in the UK. And for stellarator technologies, there have been a number of stellarators that have recently been founded, especially between 2023 and 2024. I'll go into some of those companies in a little bit, but a few other interesting players here are General Fusion, which is based out of Canada, and Kyoto Fusioneering, which is based in Japan, that's essentially doing components for a wide variety of reactor technologies. But I actually don't want to spend too much time on the actual confinement systems themselves. So I think one of the important things to call out for the fusion landscape is the fact that there is a growing and diverse investor landscape of those who are interested in investing in fusion technologies. Another one is the fact that multiple accelerators have been receiving funding. I know traditionally there's been a focus on tokamaks, which have been more mature technologies, but the fact that there have been a significant number of companies that are accelerators that are continuously raising funds, I think just shows an interesting trends towards accelerators, especially in North America and Europe. So just to kind of go over who some of the investors are, Lower Carbon Capital is a major investor based out of the US. They've invested in a wide variety of fusion players. This includes Commonwealth Fusion, Thea Energy, Avalanche Energy, and Exemer. Google has also invested in a few different companies, including TAE Technologies and Commonwealth Fusion. Breakthrough Energy is another key investor that has multiple investments in multiple fusion companies. And I think this approach where it's already risky to invest in a fusion technology, but the fact that investors are willing to invest in more than one just shows a kind of growing appetite for fusion technologies as a whole. So outside the venture capital landscapes, you do have a variety of corporates also investing in fusion technologies. There are a number of different oil and gas companies that have been involved. These include Shell Ventures, which has invested in Zap Energy, Chevron, Equinor Ventures, which invested in Commonwealth Fusions, and there are a few other players based in China as well. There's also been significant investment from the automotive industry, interestingly enough. So Neo Capital it's generally related to Neo, which is developing electric vehicles in China. And you also have Toyota Ventures that has invested in fusion technologies too. And regionally speaking, there is growing interest outside of North America and Europe. Cleantech Energy is an institution that was recently founded in Abu Dhabi, and they are also looking to invest in fusion companies globally. So there's a growing investor landscape, which is good in some regards, but I think it might make fusion companies a little over-reliant on private industry for funding. And there's always a problem where if interest for some reason dries up, how will some of these fusion companies that are very capital expensive, like how will they move forward? Okay, so this is a slide that also needs a little bit of explanation. So if you look at the left axis, I don't know if you can see it, this isn't necessarily the volume of investment going into these companies, these are the number of deals. So a lot of times companies, they might receive smaller investment amounts, maybe like 5 million, 10 million, and those don't necessarily compare to 100 million, $900 million rounds. But I think it's just important to show where certain technology types have received multiple investments. So I think what's really interesting is that in 2023, if you look at that bright teal color, those are stellarators. So that was essentially when around 6 to 7 stellarators received investment. So even if the dollar amounts maybe are not comparable to tokamaks, which I'll show in a later slide, I think this is a pretty significant spike that's worth calling out. Another key spike that's worth calling out is the dark blue, which is components. So this includes companies like Medox, which is doing high temperature superconductors in the US, and Kyoto Fusioneering. So the fact that there is more investment in the components themselves just shows that there is this kind of idea that fusion may potentially succeed in the future, but if someone's not necessarily sure what the exact reactor model will be, components is a way to get into the industry, but not necessarily specify a specific reactor model. Okay. So one other key dynamic I wanted to talk about is the fact that China has also been increasing their investments in fusion. Most of the work that they've been doing is on the public sector side, and I do have more notes on that, but that's not necessarily in this presentation. One of the tricky things with understanding the investment landscape in China is that it's really hard to identify private industry versus public industries. This is mostly because many of the companies are state-owned. So if you see a press release, something like the Chinese National Petroleum Corporation invest in Neo Fusion, most of those companies are partially state-owned, so it's a little tricky landscape when you're trying to track venture deals. That being said, 1.3 billion was invested into Neo Fusion, which is accelerating tokamak technologies in China. So it's a pretty key deal that I wanted to call out, but it's like up for debate whether or not that's considered a venture deal or not. On top of that, there was a recent deal for Pacific Fusion based in the US, which received around $900 million. So that just kind of goes to show the spike in 2024. That makes it almost comparable to 2021 numbers where we saw really big deals in the fusion industry, which I'll get into a little bit. But I think the overall growth of fusion technologies in Asia is an important dynamic to call out, especially when we're seeing a few companies in Japan like Kyoto Fusioneering, Helical Fusion, and X Fusion raising rounds. Okay, great. So this is basically my last slide. This just goes to show the overall investment into different reactor types by dollar amount. So in 2021, we had that very large deal into Commonwealth Fusion for around $1.8 billion. That was their Series B round. Helion also raised around $500 million in 2021. And then in 2024, there was that very large deal for Pacific Fusion and also Neo Fusion, which raised quite a bit in 2024. So one of the key points I wanted to highlight here is that in countries like China, it's interesting to see a consolidation around one reactor type, which is a tokamak. But when we're looking at North America, which has received quite a lot of the private investment, there isn't necessarily that same consolidation towards a specific reactor type. So I think it'll be really interesting to see as we move forward how Commonwealth Fusion, companies like Helion, Zap Energy, which also raised quite a bit this year, and also inertial confinement technologies, how these different models end up scaling as many of the different types of reactors receive funding in the US. So yeah, this is essentially my last slide. If there are any other questions on some of the dynamics, I'm happy to share some of my notes from other presentations and answer any questions here. Nope.
Are there any questions online?
Not yet.
Okay. I do have a question.
Yeah.
While we, yeah, anyone online, please send a question. So in 2024, the Z pinch.
Yeah.
So which companies?
So that one, it's still up for not debate, but so Pacific Fusion is modeling their reactor off of a Z machine.
Okay.
So Zap Energy and MIFTY are the other technologies under Z-pinch.
Yeah.
But I think I still need to just confirm whether or not that technology type is specifically Z-pinch.
Okay.
But yeah, it looks like it's closely aligned to some of those technologies that we've seen so far. But that was a very recent deal. I had to update that graph pretty recently. I think that came in like 2 weeks ago.
Okay. And then just following on, so obviously saying there's a great importance with the investments in Asia, but the economic systems are quite different. So like Korea has the tribal model and stuff. How do you think that will impact the delivery of fusion or private companies coming out of, yeah?
Yeah, I think it's really interesting because I spoke to a few different companies based in Japan. So there is a lot of expertise in Japan and Asia on components. So I think you said you're working in the materials department. So there's a lot of work on, I think, monoblocks and different types of technologies for diverters, materials that I think either Sumitomo, maybe Mitsubishi Heavy Industries, they're all kind of developing specific materials both for ITER and also for different companies. There's also a lot of expertise around high temperature superconductors. So you have companies like Burke Power Electric and Faraday factories supplying a wide variety of companies in the United States and outside the United States. I think one of the challenges is because the component industry is so well developed in, Asia, you also have Kyoto Fusioneering. It's kind of taking that expertise and leveraging it to build companies that are developing their own reactor models. So you have Helical Fusion, X Fusion, and I think at least one other company based in Japan. And there are policies that are meant to kind of support companies that are developing their own reactors in Japan. I think there's just a lot of capital expenditures that are needed to support really large projects like that. And so there is this focus on doing both, doing components and developing the reactors within the country. It's just that it feels like the components aspect has been way more commercialized than the actual reactor companies have been. But there are opportunities. I know Helical Fusion, they're leveraging the large things like the large helical device that's already based in Japan. So there's a lot of research that's already been done there. I think it's just the fact that that company is still pretty early stage, that they don't necessarily have the resources to scale quite like Commonwealth and some of the other industries in the US have.
What does the future of fusion investments look like? Because we've had big years in 2021 and 2024, then a couple of years in the middle. Is this an ongoing trend or?
Yeah, I think that's a really good question. I think some of the same drivers that I used to describe the trends for advanced nuclear and small modular reactors, I do think this will support the fusion landscape as well, especially when you have really big names like Sam Altman and Bill Gates looking at fusion technologies. I think one interesting dynamic to also look into is the fact that in the US we have a new administration. And so I think the fact that this administration is interested not necessarily on green technologies, but on energy security, if fusion falls into that category, it's possible that we still might see investments in fusion and in nuclear technologies. I think one dynamic that gets called out a lot, especially with more conservative policymakers, is the kind of race between the US and China. So when you have more of those voices in the United States, it's potential. I don't want to say what's going to happen in the future, but you do have a variety of perspectives that can support the fusion industry if they believe that they think that this is a realistic way to support the US energy landscape.
So you mentioned like Google and Amazon getting involved with it. You mentioned the new administration in the US. So is it only a matter of time before Elon Musk gets involved? And why hasn't he got involved?
Yeah, I don't know why he hasn't gotten involved in it. I'm sure everyone has their own agenda when they're working with politicians. I think one thing I am going to be keeping my eye out on, I don't know how it's going to move forward, is just there's been a lot of really great work that the US government has been doing for grant funding. So there's been milestones programs. ARPA-E has been doing a lot of work closely with these fusion companies. I'd hate to see that go away. But I don't necessarily know what the future of those programs look like. I'll be keeping an eye out for those.
Because that on the amount of dollars there, and, like that's nothing for him, is it?
Yeah, it's nice.
So yeah, he could do all that himself.
Sorry if I got that wrong, but I remember like when you showed a slide on the investment on SMR and AMR.
Yeah,
It was 700.
it was 700 million. Yeah,
Yeah, and it looks like nothing compared to fusion.
it wouldn't. Yeah,
Which doesn't make sense in my head because SMR is like a more
It's
mature
closer.
technology. You can
Yeah.
get your return earlier, so I don't know why.
yeah. So there are a couple deals. So there was one deal for with SK. So there are like a couple deals that could potentially have been included that I took out. So one of them was a $750 million investment into Tower Power. So there are larger deals, but to your point, it isn't necessarily at the same volume as these technologies. I wish I knew why specifically. I think with Commonwealth Fusion and with the recent investment in Pacific Fusion, they had a really wide variety of investors come on board. It was a very diverse group and there were just like so many of them. I want to say there were around 12 investors for Pacific Fusion and there were more for Commonwealth Fusion. So there was a lot of excitement associated with those. I think with Commonwealth Fusion, their investment was also right around the time that MIT had major announcements with the breakthroughs in high temperature superconductors. So sometimes these are tied to specific milestones. But I think what is interesting is that fusion technologies are essentially very new, so they require a lot of capital expenditures to test out the science. SMRs aren't necessarily that new. They're leveraging existing nuclear technologies. I think where the challenge is getting those partnerships. So the fact that you're getting partnerships with Kairos Power that Oklo has with the different data centers, those are essentially not investments, but those are customer relationships where they are getting paid potentially for the energy that they produce. So it's also a different kind of not investment mechanism, but how the economics play out for SMRs.
The question just about balancing priorities for these bigger
Yeah.
companies, because they previously they was both have been carbon neutral,
Yeah.
but then obviously AI's come along and took the world by storm, and so now they suddenly need to ramp up their energy
Mhm.
sort of demand. Do you think there's a risk of them just throwing out their green?
Yeah, that's a really good question. I've had this conversation with quite a number of people where it's like I was talking about their commitments to net zero. There's no federal policy that requires them to be to meet net zero. There's no policies or any consequences outside of marketing consequences outside of meeting those goals. So one of my biggest concerns is that if natural gas becomes cheaper and more available, and also if you have different policymakers, what is the incentive to potentially have a data center that is run on nuclear versus one on natural gas when natural gas is already available and easy to deploy and is pretty stable as well.
I think Maria.
I have a question.
Yeah.
So with different administrations and, like with some tensions around the world, like Ukraine, Israel,
Yeah.
this thing. So like, kind of like the investment, like, let's take like, kind of like the world as groups, like Asia, Europe, and North America. So like, where do they, with all these tensions, where do they actually invest? Because the companies like where they're concentrated, they're kind of like leading the development of the fusion or energy. Like, how does that affect like all the tensions and everything? How does that affect like every single like group of countries like North America, Europe, like the investing? Yeah.
So that's a really good question. I think so. My company and a few of the other analysts, they speak to quite a number of investors. So I know before the election, like around 6 weeks beforehand, quite a number of investors were saying that if they've gone this long without investing in a certain technology, they can wait another 6 weeks to see what happens and then invest. And I think one of the challenges again is like any technologies that kind of benefit off the IRA. What are the risks associated with there? Because there are different levels of risks. So say, for example, a company is based in the US and is able to leverage the domestic manufacturing tax credit, where if they're developing and manufacturing their technology within the United States, they receive a certain rebate. It's possible that many of those tax credits are based in more red states where a lot of those policymakers may actually want those policies to stay there because it's supporting the economics of that state and of that region. At the same time, there are different types of programs where is funding involved for specific projects. And I think anytime funding is allocated for certain technologies, that's where I think there might be a little bit more risk associated with that. But I do think that there are investors and institutions based in Asia that may have previously been looking at technologies, and this is outside the fusion landscape. They may have previously been looking at technologies based in North America, but they now might be looking more towards investments in Europe and in other regions as well. Yeah, no problem.
I believe there are also other investment in other renewable energy technologies.
Yeah. Mhm.
If we compare the nuclear technology and other investment in other renewable technologies, is it very much or it can be?
It's interesting. So I think one of the interesting dynamics with nuclear is that these deals are very high volume. So 1.8 billion, 900 million, even for TerraPower, 750 million. These are very abnormal in the clean tech sector. We do have produced a quarterly investment insight where all the sectors kind of show how much investment has gone into each specific vertical. And most deals are not this high. Most maybe some of the bigger deals may be around 300 million, but for fusion, that's actually not the biggest deals that we see. So there is a lot of volume going into these technologies. I think one of the challenges is the sector as a whole is still very early stage. We haven't had a private company achieve break even yet. There's still a lot of unknowns. So I think it is exciting that there is a lot of money going into this space, but at the same time, there are other areas of clean tech, whether that's like different ways to decarbonize green steel, materials, different areas within EVs, building decarbonizations, where if the goal is to achieve net zero, there are other ways to invest that maybe smaller volume deals may go a little bit further.
In overall, the nuclear technology attracts all the investments.
Fusion deals are some of the biggest deals we see all year, especially in 2021 and 2024. There's been, when we look at the graphs of like where money is going for the different sectors, one of the biggest kind of parts of that pie is fusion.
And my second question is that we see that the data storage and AI may drive the electricity demands in the future.
Yeah.
We use the other other demands globally, which may increase the electricity consumption a lot in the future.
Yeah, I think one aspect I didn't get into now, which I think is really interesting. So Core Power is doing nuclear fission for maritime applications, and then there's a company called Avalanche Energy that's doing modular fusion. They're building a pretty small reactor. I forget what the size actually is, but essentially, if you can tackle the transportation and shipping industry, those are very, very large industries that are also in desperate need of decarbonization. I think the pathway there is a little bit harder than potentially data centers or chemical manufacturing, because those are stationary applications. But if you can tackle transportation, whether that's aviation, shipping, those are pretty big markets that you can get into as well.
Like to go back, you made a point on his first question about sort of the kind of the comparative between the volume of energy going into nuclear versus renewables. So would you not necessarily expect the higher investment in nuclear to yield a larger output than the investments in renewables, simply because nuclear does have this slight tendency to hoover up huge amounts of capital with very little output?
Yeah.
How expensive it is to put nuclear on the grid.
Exactly. So I think we do see way more deals in every other sector outside of nuclear. It's just that when you're comparing volume to the number of deals, those charts are a little bit interesting. So like this chart is by investment amount. When you look at a deal like this, tokamaks don't look like they've received quite a lot, but those tokamak deals are, like 1.8 billion. This is just the number of deals. So even though we see way more deals in every other sector outside of fusion, there is that kind of allocation specifically towards fusion technologies. But I think you also have people investing in fusion that may not have invested in other clean technologies, right? So although, companies like Toyota Ventures may invest in a number of different technology types, the fact that they invested in avalanche energy suggests that they potentially think that there are applications in the transportation sector for technologies like avalanche energy. So you do have some kind of like movement and shift where renewable dollars might be going to the fusion industry, but you also have the ability where you have like Sam Altman and a lot of other technology providers investing in fusion and nuclear because they see that as the solution and not necessarily other renewable technologies.
Okay, so confidence is more from the diversity of the funding sources rather than the volume of
Yeah.
both of them together.
Yeah, I think both of them together, because you also have people investing in fusion that may not have invested in other clean technologies.
Do you think these large companies are then kind of, if they're not investing in the renewables as much as maybe they should be, are they kind of
They might be doing wait and see.
greenwashing or kind of just putting all their eggs in fusion because a lot of people market it as a silver bullet?
Yeah, and I think that is one of the challenges when you have a company that, when you have like oil and gas companies that are looking at a variety of different technologies and they're also investing in fusion, you have to kind of think, is that because they think fusion will succeed and they're trying to diversify their portfolio for when it does, or are they doing to do that just because it looks good on, in a portfolio alongside other technologies like green hydrogen, which, there's some different speculation on how that industry might move forward as well, and what the commercial applications for green hydrogen would be.
I think another aspect is they do need electricity to keep running their business on AI and data storage. And they need to, I think different like giant company, they are competing for the electricity and they are building data storage, not just in US and also elsewhere, so that they can get enough electricity to like boost their business in the future for AI and data.
One last question. Sort of regards to the nuclear sector where this is happening now for a future promise, I guess, like we haven't seen a fusion reactor yet produce power as such.
Yeah.
So when it comes to companies like Google and they're, so Microsoft wants to acquire a nuclear facility to power a data center which hasn't been built yet. So what's the lead time on that, do you think? When we start seeing these huge data centers?
Yeah, I think there's this kind of discrepancy between like solutions that will help us achieve net zero versus solutions that will help us maintain net zero. So if we're thinking about in a hypothetical world where everyone is net zero by 2050, ideally, you're still going to have growing energy demands. And so just because you've achieved net zero, you're still going to need more energy production. So fusion technologies are still going to be required after a certain point. I think where some of the marketing language might be a little bit challenging is like when certain milestones are kind of projected. If certain technologies and companies say that they're going to be grid connected and producing electricity by a certain time, then they kind of are trying to enter that we will help, data centers and the world transition to net zero. But I think that it's going to require a number of solutions to help us get to net zero. And then if fusion is able to deliver on this promise, it could potentially be one of the biggest ways that we generate energy moving forward. Any other questions? These are all good questions. No? So I think we're at time.
Yeah, it's gone 1:05. I think we have the room for another half hour or so people are welcome to stick around and network or just ask Zainab more questions if you have them. But really appreciate the talk. I don't think we get to see this very often in academia, so it's nice to have someone come in and explain a bit of forecasting to us about investment. I find it very interesting.
Yeah, I appreciate that. I know it wasn't the most technical conversation, but I feel like it's always helpful to just provide some context on some of the research that's happening.
It's the bigger picture. I think it's always important to bear in mind. So another hand, please, for. Thank you. Yeah. That's it.
Thanks for inviting me.
People take this when you go to
It'd be great if we could some of the slides, even if it's just